Welcome to Precalculus Concept 27a underneath graphs of sine and cosine. We are going to talk and understand the graph of y equals sine x. There are 3 boxes for this lesson. This is a very important lesson, so if you are not quite paying attention, make sure that you wake up and get some water and some tea and whatever it is that you need to make sure that you pay attention to this particular lesson, because it's very imperative that we understand where this graph comes from. Okay, there's only 3 boxes, so here is the first box. It is entitled y equals sine x. Where does it come from? So what we're going to do is we're going to start with the completed unit circle as you see here on the left-hand side. Now I know we haven't specifically yet talked about how to fill this out. We will, but for now I just want us to focus on the completed unit circle, and what we're going to do is we are going to focus only on the y coordinates. How come the y coordinates? Well, you may remember that sine of x deals with all of the y coordinates. So if I look at and I highlight all of the y's, I have a 0, I have a 1/2, I have rad 2 over 2, I have a rad 3 over 2, I have a 1, and I'm going to keep going all the way around the unit circle, and I'm only concerning myself with the y coordinates because, of course, we know that the sine function deals with all the y values. Okay, so the y values there that I've highlighted for you are going to be a part of the graph. And the x coordinates, what we're going to do is we're going to take these degrees in radians, such as, I'll do these in like a different color for you, so like blue. So pi over 6, pi over 4, pi over 3, pi over 2, all of these ones that I'm doing in blue for you, pi, 7 pi, blah, 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 all these around here, okay? What we're going to do is we're going to label the x-axis in our angles, and the y-axis is going to be our values. So here we go. It's going to look like this. So I would encourage you to follow along with me as well. So the x-axis, these are going to be our angles, our radian measures. And I'm only going to put a couple of them on there for you. I'm going to put 0 on there. And then I'm going to put pi over 2. So I'm going to put this one here. Oop, sorry about that. Okay. Then I'm going to put pi. So I'm going to put this angle over here. Pi. Then I'm going to go down here to 3 pi over 2. 3 pi over 2. And then finally I'm going to finish off with 2 pi. Okay. Now the biggest value, so the y coordinate is going to be the values of all the ones that I've highlighted for you. So what I mean for that is the biggest it can be is a 1 right there, and the lowest it can be is a -1. So I'll go down 3 and it's a -1. So what we're going to do here is, in order to generate the graph of sine of x, we just simply plot each of these coordinates onto the coordinate plane. So as an example, when at 0 radians, I have a 0 output. So I know 0, 0 is on here. At pi over 2 radians, I have an output of 1. So at pi over 2, I have an output of 1. At pi radians, I have an output of 0 again, right? The y coordinate is 0. At 3 pi over 2, I have an output of -1. So that's down here. And finally, at 2 pi, I end up right back where I started with. Now, it turns out that if I did this for every single angle, like all the ones that I even skipped in between, what you would get is you would get this nice, smooth looking curve that looks like this. And this is one full complete cycle of a sine curve. Notice that it starts at 0, it rises to a maximum at 1 at pi over 2 radians. It falls back down and hits the x-axis again at pi radians. Then it falls to -1, lowest spot at 3 pi over 2, and then comes back up to 2 pi and 0 at 2 pi radians. So basically all we're doing to get this graph is we are unraveling the unit circle into 2 dimensions of an x and a y. So this is really important, and hopefully that made sense to you. So box number 2 is a quick skill. We're going to learn how to quickly sketch a basic sine curve with 5 easy points. And I kind of already did it for you, but here's the idea. We're going to give yourself a coordinate plane and give yourself a positive x-axis, all right? We're going to always put 0, and then I'm going to skip 3 lines here, or 3 points, and then put pi over 2, and then put pi, and then put 3 pi over 2, and then put 2 pi. And that's all you really have to do. you'll notice that these are all the quadrant angles, right? So pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, and then 2 pi is of course 360 degrees. And then the highest it can be is a 1, and the lowest value it can be is a -1, meaning the output values. And the 5 points that you need are here. It goes medium, high, medium, low, medium. So there are your 5 points. 1, 2, 3, 4, and 5. All right? So when we're talking about the graph of y equals sine of x, we need to be able to make this sketch really quickly at a moment's notice. So right now I want you to practice making that sketch again. You can look at this if you need to, but just make one little quick sketch on your own in the video. Okay, box number 3 is all about the important parts of the sine of x. So I have a nice graph for you. Notice I have the 5 important dots that we've just discussed in box 2, and we're going to cover all these things on the right-hand side. So first, let's talk about the domain. Remember, the domain are angles that we are putting into our function. And as you can clearly see, there is no angle for which it's undefined. So therefore, our domain for sine function is going to be all real numbers. And when I'm saying real numbers, I'm talking about any angles that I'm putting in. And those can be radians or those could be degrees. The range, however, is different. The range is trapped between +1 and -1. So this is our range. So it is between -1 and 1, and you can represent it just like that. Next, we'll talk about where is this graph increasing. Well, it's increasing if I'm just considering the interval from 0 all the way to 2 pi, then the graph is increasing from 0 to pi over 2 because it gets bigger here. And notice it's also increasing from 3 pi over 2 all the way to 2 pi. Now I'm only considering in this little box here, okay? So it's going to be increasing. If I'm talking about from 0 is less than or equal to x, less than or equal to 2 pi, just on this interval, it would be increasing from 0 to pi over 2, and also increasing from 3 pi over 2 to 2 pi. Okay? I'll use parentheses for that. Similarly, if this thing is decreasing, it's decreasing from pi over 2 to all the way to 3 pi over 2. So I would just say from pi over 2 all the way to 3 pi over 2. Okay? The x-intercepts are anywhere where the graph crosses. So it crosses there, and it crosses there. So it looks like it crosses at 0, crosses at pi, it crosses at 2 pi. So it looks like it's like any whole integer value of pi's, as we would say for that one. But if I'm only considering the interval from 0 to 2 pi, it would be 0 pi and 2 pi. And notice that sine of x is an odd function. So what the heck does that mean? Remember that the sine of -x is the same thing as the negative sine of x. So we're going to use that one from time to time. And also to note that the sine function is symmetric with the origin. That's what odd functions means as well. Okay, lots to remember there, but that is those are the important parts for y equals sine x.